Welcome back, guys. We're going to do the great infiltration experiment today. Miss Maxitai is back with us today, and I'm Mrs. Woodyard,
Miss Mondini.
and we're being joined today by Mr. Miller and Mr. Barrett, and Mr. Schnurr is doing the camera. No Mr. Lewis today. All right, so you guys, make sure your notebook is open to the great infiltration experiment. And our research question today is, do all types of sediment allow water to infiltrate at the same rate? So Miss Mondini is going to show you the types of material that we're using today.
Yes, here we have sand, we have gravel, and we have clay.
Looks different than your modeling clay, right, that you played with as a child, right? Okay, so if you look at the method, which is the next step on your sheet, it says we're going to place those 3 different types of sediment into 3 cups with holes in the bottom. So I'm going to have Mr. Schnurr, you see we have holes in the bottom. And then you can probably see it best on the gravel. We have a piece of coffee filter so that the materials won't fall through the holes when we pour water in there. All 3 cups have holes. All 3 cups have coffee filter. And we tried to put the same amount of sediment in all 3 of the cups. Okay? And then we all have 100 milliliters of water in our beakers. So we are going to pour 100 milliliters of water into each cup. So the first thing you guys need to do is answer the question that says, what variables are we controlling in this experiment to make sure our results and conclusions are valid? So please pause the video right now and fill that out. Okay, great. Now you guys are going to make a hypothesis. So the question is, will all 3 of these materials allow water to pass through at the same rate? Now, Miss Mondini, how will I know when water has passed through?
Well, we'll be catching it here in this bucket below, and we need to time that to answer a research question. So we have 3 timers, and each one is assigned to watch a different bucket. So the second we pour the water, they're going to hit start with their timer, and the second the water hits the bucket, they're going to hit stop.
So before we do that, you guys need to record your hypothesis or your testable prediction. Make sure you justify your prediction with logic and reasoning. So please hit pause right now in the video and record your hypothesis. All right, so here we go. We are ready to begin pouring the water. Mr. Miller is going to time sand. Mr. Barrett's going to time gravel, and Miss Maxitai is going to time the clay. So Miss Mondini will say when we're ready to start pouring. Okay.
All right, 1, 2, 3, pour.
So you'll notice, guys, that sand and gravel have already started dripping. So Mr. Miller and Mr. Barrett have already hit stop on their stopwatches. Miss Maxitai, however, is still waiting on clay. So Mr. Schnurr, can you get a close-up and show them how water has started to seep through or seep into the clay, but we have this very big pool of water left on top? And then if you jump down to the sand, you can see, Miss Mondini, I don't know if you can point out that there's still some water.
You can see all the water in between the sand particles here, making the sand wet all the way through. And then you can see that the gravel here is wet as well from where the water has passed through.
And Miss Maxitai's clay has only made it down about that far, and she is still running her stopwatch.
Still totally dry at the bottom.
So while Miss Maxitai keeps her timer going, Mr. Miller, how long did it take for the water to start dripping out of the sand?
6.65 seconds.
And Mr. Barrett, how long for the gravel?
3.80.
Thank you. And we are actually just going to pause the video because if we left you guys sit here and wait on Miss Maxitai, you'd be twiddling your thumbs. So we'll keep the timer running and we'll report to you in class what the number is for clay. Thanks, guys.